we already completed the electrode potential, how electrode potential is developed and how can we measure electrode potential. Then we can measure electrode potential using a reference electrode, and we have seen the standard hydrogen electrode as the reference electrode. The electrode potential of standard hydrogen electrode is 0 volt. This much we have completed yesterday. Now today what we are going to do is the relationship between electrode potential, concentration of the electrolyte and temperature. How do the electrode potential varies with the concentration of the electrolyte and temperature. The relationship is given by Nernst equation. Now consider the electrode reaction. Mn plus n electrons gives M. Why I have taken this as the electrode reaction? Because we consider all the reaction taking place at an electrode as reduction according to IUPAC. So you write the reduction. This is a reduction reaction. Mn plus ions accepts n electrons and form M solid. Now this equation, the electrode potential of this equation E is equal to E Mn plus bar M is equal to E naught. That is standard electrode potential by M minus RT by NF ln molar concentration of M by molar concentration of Mn plus. This is the expression that gives the relationship between the standard electrode potential and electrode potential at different conditions. When concentration changes and temperature changes, the electrode potential also varies, and this expression is called the Nernst equation. Nernst equation. So this is for reduction, and reduction potential Mn plus bar M is equal to E naught Mn plus bar M, where E naught is the standard electrode potential, R is the universal gas constant. R is universal gas constant. And what is its value? Its value is 8.314 joule Kelvin inverse mole inverse. Then T is the temperature in absolute scale, N is the number of electron accepted, F is Faraday's constant. And what is its value? Faraday's constant. Its value is equal to 96,500 coulomb. So Faraday's constant. Then Ln is logarithm to the base E. Then M is the molar concentration of M solid, and Mn plus is the molar concentration of the electrolyte. Now, if that is equal to E naught Mn bar M minus R value we know it is 8.314, and T is standard with the temperature, alternate temperature if you take, it is 298 Kelvin by N is the number of electrons accepted, and F Faraday's constant 96,500, then into, to convert logarithm to the base E to the logarithm base 10, we multiply it with 2.303. So 2.303 log 2.303 log molar concentration of M by molar concentration of Mn plus. Now, molar concentration of M solid is always taken as unity. Molar concentration of M solid is taken as 1. So then we can write this equal to E naught Mn plus bar M minus C. If you multiply and divide this all, these are all constants, they will not change. Temperature we are keeping a constant, we are changing only the concentration. So if you keep the temperature also a constant, then if you multiply all this, you get 0.059 by N log 1 by Mn plus. This is the electrode concentration at any concentration, electrode potential at any concentration you can calculate if you know the standard electrode potential. Standard electrode potential is the electrode potential when the concentration is 1 moles per liter. Understood? So this is Nernst equation for an electrode. So Nernst equation for an electrode, general electrode, this is Mn E Mn plus bar M is equal to E naught Mn plus bar M minus RT by Nm ln molar concentration of M solid by molar concentration of Mn plus, where R is the universal gas constant, T is the temperature in absolute scale, N is the number of electron accepted, and F is Faraday's constant. Out of this, R and F are constant. If you keep in temperature a constant, T is also a constant. Then log ln is the logarithm to the base E. You will have to convert to the logarithm to base 10. You will have to multiply it with 2.303. So if you do all these constants, you will get 0.059 by n log 1 by the molar concentration of Mn plus. Now, this is for just an electrode. Now, if you know the electrode potential at any concentration, how can you calculate the the cell potential if you know the electrode potential at a different concentration? Now, what is cell potential? Cell potential is equal to E cell is equal to, or EMF of the cell, E is equal to E cell is equal to E cathode minus E anode. E cathode minus E anode. Now consider the galvanic cell, the Daniell cell, that is zinc solid, zinc 2 plus aqueous, then Cu2 plus aqueous, Cu solid. This is the Daniell cell with the concentration, molar concentration, different concentration. So consider this Daniell cell. Then what is cathode here? Copper. So that is equal to E Cu2 plus bar Cu minus E Zn2 plus bar Zn. That is E cell. And what is E Cu2 plus? E Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu minus 0.059 by how many electrons here? We can take again generally n electron in log 1 by molar concentration of Cu2 plus. Now, what is E Zn2 plus bar Zn? Bar Zn is equal to E naught Zn2 plus bar Zn minus 0.059 by n log 1 by Zn2 plus, molar concentration of Zn2 plus. So we know E copper electrode and zinc electrode. Now what is E cell? E cell is equal to E cathode minus E anode, isn't it? So that means E1 minus 2. So E cell is equal to E cathode is E0 Cu2 plus bar Cu minus 0.059 by n. N is 2 actually here. Then log molar concentration of 1 by Cu2 plus minus E naught Zn2 plus bar Zn minus of this one. So 0.059 by n log 1 by Zn2 plus. So it is E naught Cu2 plus bar Cu minus E naught Zn2 plus bar Cu is equal to E naught cell minus you take 0.059 by n, 0.059 by n, then here it is minus of log Cu2 1 by Cu2 plus minus of minus is plus log 1 by Zn2 plus. Now log A minus log B is log A by B. So we can write E cell is equal to E naught cell minus log of 1 by Zn2 plus by 1 by Cu2 plus. Minus 0.059 by n log now that is E naught cell is equal to E naught cell minus 0.059 by n log of 1 by Zn2 plus by 1 by Cu2 plus, because this E0 cell minus 0.059 by n log 1 by Cu2 plus minus log of 1 by Zn2 plus, that is equal to log of 1 by Cu2 plus into molar concentration of Cu2 plus. This one will go reciprocal because log A minus log B is log A by B, that is log of 1 by Cu2 plus by 1 by Zn2 plus, isn't it? So 1 by Zn2 plus, so it will reciprocal, you will have to multiply, so Zn2 plus will go up. So this is equal to E naught cell minus 0.059 by n log Zn2 plus by molar concentration of Cu2 plus. So E cell is equal to E naught cell minus 0.059. In the case of zinc copper, this will be equal to 2 log molar concentration of Cu2 plus by molar concentration of Zn2 plus. This will give you, now this is the anode concentration. Anode electrolyte concentration is the concentration of cathode compartment. So if you are writing, this will be the concentration of the anode compartment and this will be that of the cathode compartment. So this is E cell is equal to E naught cell. If you write this one as positive plus, then you can write E cell is equal to E naught cell plus 0.059 by n log molar concentration of Cu2 plus by Zn2 plus. You can write this also. It's also correct. Because then it will be plus here. Because we have plus here, then it is minus of log A by B. So that will become, this will go reverse up. So we will get molar concentration of Cu2 plus by molar concentration of Zn2 plus, then it will be plus here. So you see the equation. So from the Nernst equation, we are calculating E cell. E cell is equal to E cathode minus E anode. We are considering the Daniell cell. The Daniell cell, the cathode is copper. So E Cu2 plus bar Cu is equal to E naught Cu2 plus bar Cu minus 0.059 by n log 1 by Cu2 plus, and similarly you like that anode Then E cell is equal to E naught cathode minus 0.059 by n log 1 by Cu2 plus minus of this one. Then E naught Cu2 plus by E naught Cu2 plus is E naught cell minus 0.059 by n you take outside. Then minus of 1 by Cu2 plus, then plus. And here since I am taking minus outside, then this is plus, this is minus. So you will get E naught cell is equal to this one, and from that you got E naught cell is equal to E cell is equal to E naught cell minus 0.059 by n log molar concentration of SN2 plus by molar concentration of Cu2 plus. So this is the E cell of the reaction. See, a voltaic cell is set up at 25 degrees Celsius with the following half cells. Ag plus 0.001 molar bar Ag and Cu2 plus at 0.01 molar bar Cu. And E naught value are also given. You have calculate the E cell. Calculate the E cell. How will you calculate the E cell? Now what is E cell of this cell? First you have to construct the cell. See, you are given Ag plus Ag, E naught value and Cu2 plus. See, both are positive. If both are positive, that means both are having a higher tendency to get reduced. Then which we will take as the anode? The one which has lower positive value. This will be the anode and this will be the cathode. So first construct the cell. E Cu2 plus, Cu solid bar Cu2 plus. When you are writing the anode, first write the electrolyte, then the electrode, then the concentration 0.01 molar, then Ag plus, what is the concentration? Ag plus aqueous, what is the concentration? 0.001 molar bar Ag solid. This is our cell. This is anode, this is cathode. Then what is E cell is equal to? E cell is equal to E naught cell minus 0.059 by n. Now, here log molar concentration of the anode by cathode. Before writing this, we will have to write the electrode reactions. What are the electrode reactions? You see at the anode, that is Cu gives Cu2 plus Cu, because Cu will be plus 2 electrons. At the anode, oxidation is taking place. At the cathode, reduction is taking place. Ag plus electron gives Ag, isn't it? But here there are 2 electrons, here only 1 electron, you make it 2 electrons. You will have to balance the electron. So, cancel. So, Cu plus 2 Ag plus gives solid, aqueous. Cu2 aqueous plus 2 Ag. So, which is oxidized? Copper is oxidized, and which is reduced? Silver is reduced. So now we have to take the anode concentration. What is the anode concentration? Copper. So molar concentration of Cu2 plus by, what is the anode concentration? Ag plus. But there are 2 Ag plus, so you will have to write Ag plus square. So this is the expression for this cell. Now what is E0 cell? E0 cell is equal to E0 cathode. What is E0 cathode? The silver. That is E0 cathode. That is Ag plus bar Ag minus E0 anode. What is E0 anode? Cu2 plus bar Cu minus 0.059 by n. How many electrons are accepted or released? Gives 2. So by n2 log molar concentration of Cu2 plus. What's molar concentration of Cu2 plus? 0.01, that is 10 raised to minus 2 divided by what is Ag plus concentration? 0.001, that is 10 raised to minus 3 raised to 2, so that is square. So that is equal to, this is what is Ag plus bar. Ag is 0.80 minus 0.34, then minus 0.059 by 2 log molar concentration of, this is 10 raised to minus 2 by 10 raised to minus 6. So you can cancel it. It will become 10 raised to minus 4 down. When it goes up, it will become 10 raised to 4. And log of 10 raised to 4 is equal to 4. This is 0.46. 0.46 minus 0.059 by 2 log of 10 raised to 4 is 4. So it is 2. You can multiply and minus it, you will get the E cell value. Do it and tell me.